All right, here we are in example B. So we're supposed to find the maximum and minimums of this function. And there's a new derivative rule that I put right in here for you. It's the easiest derivative rule in calculus. You just don't know it yet. But the derivative of e to the x is e to the x. In other words, if you have some function that's equal to e to the x, okay, and you want to do its derivative, h prime of x is also going to be e to the x. You can't beat that. That's as easy as it gets when it comes to derivative rules. So there's a new derivative rule for you. The derivative of e to the x is e to the x. We're going to need that within this problem. So let's go ahead and attack this problem. It says find the maximums and minimums. Well, looking at the graph, they provide a graph over here for us. And by the way, this would be a non-calculator question on the AP Calc exam, so let's do it without touching our calculator. They gave us a graph. Well, I know right here is one of my minimums. I just don't know exactly where that is, okay? But I know the slope of the tangent line at this point has to be 0, because the slope at a max or min is going to be straight across, so I know the slope has to be 0. And it's the same with this max that's, I don't know, right in here somewhere, there's a max. Well, I know that slope has to be 0. So what I can do to find max and mins is do the derivative of this function, which is the slope at any point. That's what a derivative is. And I can set that equal to 0, and that will find the x value where the slope is 0. In other words, that'll find the x values of this min and this max. So let's go ahead and do it. Let's do the derivative of this thing. So I'm going to have the quotient rule, low d high minus high d low, square the bottom, and away we go. So I'm doing the quotient rule here. Low is just x squared minus 3. D high, the derivative of e to the x is e to the x. Can't beat that. Minus high d low. So I'm going to take the high, e to the x, times derivative of the bottom, which is just 2x. And all that is over the bottom squared. So x squared minus 3, the whole thing squared. All right, and I can simplify this a little bit. It's however you want to attack it. I'm going to go ahead and just set it equal to 0 right now. I don't know. It's not. I guess, you know what? I'll go ahead and distribute the e to the x. So I'll have e to the x, x squared, minus 3 e to the x. And then I'm going to have a minus 2x e to the x. And all that's still going to be over x squared minus 3 squared. And I'm going to go ahead and find max and min, so I'm going to set this equal to 0. Well, if you think of cross multiplication, I'm going to take 0 times bottom. The whole bottom is going to become 0, and it's going to equal the top. So in other words, you only have to set the top of the fraction equal to 0 to find the zeros of this answer. So I'm going to go ahead and just set the top of the fraction equal to 0. And I can pull an e to the x out of all 3 of these terms. I'm going to do that. So I'm going to have e to the x outside of x squared. And I'm going to rearrange my order to see it better. I'm going to put the minus 2x in the middle and the minus 3 at the end. That way I can easily see the quadratic for this thing. That's still equal to 0. Now I can go ahead and factor this quadratic, and I'll have easy access to all my answers. So I'm going to have an x. Let's see, it'd be to get a negative 2 in the middle, I'll have a minus 3, and I'll have a plus 1 for my other term. That's equal to 0, and then I can split it into 3 equations. So I'm going to have e to the x equals 0, which if I try to solve that, sorry, get off there. I do a natural log each side to cancel that. Well, natural log of 0 is undefined, so I'm not going to get an answer to this one. That term is just not going to give me an answer. No big deal. I'll get answers from the other ones. So I'll have my x minus 3 equals 0, which means x equals 3. That's where this maximum right here is. Oh, man, it was right at 3 is where that maximum was. All right, nice numbers. All right, and my x plus 1 equals 0. Well, that means I have negative 1 is a max or min. Oh, look at that. This is right at negative 1 is where this minimum is. I'm not done with the problem yet. That found the x values of the max and mins. I still need, it said find the max and mins. It didn't say just find the x values of them. I still need my y values. So I'm going to take these values and I'm going to put them in the original function to get my y values. So I'm going to do f of 3. And when I do f of 3, I'm going to put 3 in here. I'm going to do e to the third over 3 squared minus 3. And that gives me 3.348, which fits my graph. That looks like, okay, that can be about 3.3-ish. Sure, I'm going with that. Sounds good to me. So there's my max. And this would be a local max, because I do have other points that go above it. But this, or I'm sorry, I said max. This is a min. My goodness. There's my min right here. It is a local min. There's other points below it. But it would be at 3.348. Carry 3 decimals. Preparing for the AP Calc exam. And then my, wow, I even labeled it max. That's embarrassing. All right, let's do the local max that is over here. So I am going to put -1 in. Again, I'm going to do f of -1. So I'm going to put my -1 in here, do e to the negative first, -1 squared minus 3, and I will get -0.184. There's my y value. And that seems like, yep, it was just below the y-axis, or I'm sorry, the x-axis. So, yep, that seems like a reasonable y value. So there's my max. There's my min. All done. There you go.